At AV&R, our mission is to humanize robotics. We decided to create this podcast series to help you demystify the world of robotics and discover what some of the brightest minds in the field are doing. Welcome to Robotics for All Podcasts by AV&R.
Dr. Thuc Vu is the CEO and co-founder of OhmniLabs, which is a Silicon Valley-based robotics company focused on providing demand-driven robotic solutions for businesses. Thuc and his team have delivered more than 4,000 robots into 48 different countries, centered around their modular robot platform, unlocking customer-driven design and innovation. Alongside Thuc, we remotely drive one of their Telepresence robots on a tour of their state-of-the-art manufacturing facility where they boast their own 3D printers spawning robots daily. We talk about some of the latest solutions coming from OhmniLabs, as well as current events and trends driving the industry forward. Hope everyone enjoys the show. Here we go.
Thank you very much for taking some time with me today. I'm really excited. I have to be honest, this is my first time driving a Telepresence robot, so I hope I don't hurt anybody. But it's been a dream of mine because I've got 3 kids, but myself and my 2 boys, we watched a sitcom TV show called Community. I don't know if you know that one. And of course, there's one episode where they do remote education for inmates. And it was just a hilarious episode. I don't think it was your robot. I checked it out. It didn't look like one of yours. It should have been. But anyways, just to say thank you very much. And I'm super excited to have the tour.
Yeah, likewise here. Thank you for having me and welcome to OhmniLabs.
Very good. Okay, let's get started. I'd love to have a look around, and while you're going, you're the founder of OhmniLabs.
Yes. So my name is Thuc, and I'm the CEO and co-founder of OhmniLabs. And we started OhmniLabs in 2015. So it's been a few years.
Yeah. And from what I understand and looking at the background, and I listened to some of the other podcasts you're on, you started with some custom a modular robot platform and the goal of democratizing robotics. So it'd be great as we go around, it'd be great to hear your philosophy and how you approach robots.
Yeah, absolutely. Yeah. So let's get on with the tour. Okay. And then a lot of these philosophy, right? Like the brochure will show.
So I'm going to start driving. Avoid the bicycles and the tables.
So you are in a facility in Silicon Valley near the San Jose airport. There's quite a few of the robots here. So these are the UV disinfection robots. Essentially robots that would use UV light, the UV light bulb here, to disinfect a room, whether it's an operating room, patient room, or schools, classes.
I really like how you drive the robot around with the handles. Was that trial and error? How did you come up with that?
Yeah, so this is actually through a lot of product testing and talking to the operators. So we designed the robot to be super lightweight. So it's about 60 pounds and easy, very smooth to handle, to push around. We spend about a month, doing disinfection every night at Stanford Hospital.
Okay.
And we heard story of operators were using some other solution in the field, and those weigh about 300 pounds.
Okay.
And some of them actually got hurt, disability, from just like pushing those heavy machines, every night, right up the ramp. And so we're like, okay, we got to make it something very light, that can be easily, move around and deploy. So
that's really smart. There's here in Montreal, that's where I'm based. The Montreal General Hospital, they have a pilot project where they have a robot from another manufacturer that they're testing out. And I think it's more in the range that you were saying, 300 pounds and plus.
Yeah.
And it's also much wider than footprint than yours. And they have a lot of trouble with doors. So I can see that yours is really designed for tight spaces and smaller, getting through doors and stuff like that.
And that's the key, right? Because when you clean, let's say, an operating room, you want to clean on both sides of the operating bed, and then like the bathroom, like like tight corners, tight spaces. So yeah, so that's why we designed this to be having very small footprint.
Okay. And your background, are you more software engineer? Are you more into the hardware side of things, or a bit of everything?
I'm more on the software side.
Okay.
So I did my PhD at Stanford on AI, multi-agent system. And so yeah.
Okay. Okay. Very cool. Let's keep going. I'm
All right.
very eager to
So
drive
follow
this.
me. Yeah. Kind of cool, huh? And by the way, we would love to talk to Montreal Hospital if you have a connection
Oh,
there.
absolutely, I do.
Yeah, because I think our solution is way better than
Yeah.
any other manual solution, right, in the market. Yeah, right down here, you can see a lot of the team members in action. Yeah, so if you turn to the right, yeah, so you can see so these are like the assembly line where we building our robot.
Now, how many robots have you built over your 5
We
years?
actually have deployed over the last few years. We have deployed more than 4,000 robots in 48 countries.
Wow. Wow.
Yeah.
Congrats. That's great.
Thank you. Yeah. Coming down. So these are getting tested, QC, and getting ready for shipping out. You can take a look here.
Okay.
This row of robots.
Now, how's your experience been with, you're talking about the disinfection in hospitals. How's your experience been in people adopting the robots? Has there been a lot of hurdles, regulations to get through in order for them to embrace this technology?
Yeah, absolutely. So I think, there's like a before the pandemic, right? Even though robotics have been around for decades, and the promise of adoption of the values robots can bring to the end user have been around, but we don't see a mass adoption
Right.
yet. And it's still a novelty. But after the pandemic, I think things have changed dramatically.
Yeah.
Because of shortage of laborers, because of the safety of patients. We see that the adoption is a lot easier and faster.
Yeah.
Than before.
Yeah. I can tell you here, like the workforce in the hospital, they're really understaffed. And I don't know if it was the same in California, but in Montreal, we went through two moments where we had a curfew simply because our hospitals were not able to handle the capacity. So between 8:30 at night and 5 a.m., everybody had to stay inside of their house in the province of Quebec. And so there's got to be, I keep thinking there's got to be a way for us to embrace this technology.
Absolutely.
Some of the feedback that I've heard from, and maybe you can speak, I don't know if you've seen this in different regions, I find in the Canadian system, some of the regulations have been hard, or the administration has been hard to find the right people that would be the ones that say, yes, we want to deploy this technology and be able to look at it a province-wide basis and deploy it. Have you had to go hospital by hospital building that relationship, or is there in California, is there a governing body that is able to do that?
So right. So it actually, a hospital system based rather than hospital. There are like these large hospital system in the U.S. and they have different regulation in terms of adopting new technology. But it's actually a very complicated picture when you want to get adoption of a new technology in a hospital.
Yeah.
There are a lot of key stakeholders. Not only the operators, but also like here, our champion is usually like PVS directors, right? People who are in charge of facility management, but they still need to get buy-in from say infection control department.
Right.
They still need the budget to be approved by like the CFO,
Right.
right?
Right.
And so it's getting complicated,
Yeah.
to get the robots out there and deployed.
Yeah. Yeah. Okay. Okay. Let's continue.
But we're learning, and I think one of the I guess the positive sign is that because the huge shortage of labor, so hospitals are a lot more motivated these days to adopt new technology.
Yeah.
Um, so I don't know if you know the number, but they estimate about 23% of healthcare personnel quit last year. Which
Wow.
is insane, right?
Wow.
And now they struggle to find the new staff.
Yeah. Yeah. We have similar numbers here in Quebec, and it's still a challenge. And in general, when AV&R, in the business that I'm in, when we go into a manufacturing facility locally, they're missing 20, 25 people easily to fulfill the orders that they have. So it's not just hospitals, it's manufacturing. It seems to be everywhere, which it's one of those conundrums where we've never had more people on the planet, but we're not sure where everybody is, or they don't want to do these jobs. And the hospital job it's not an easy job.
Right.
So
Absolutely. Right.
there's
take a lot of training,
Yes.
a lot of testing. Yeah, and it's crucial. It's very critical that we have people in hospital, right? Because without the caregivers, basically patients are the one who's suffering the most. So
Yeah. Now, a big part of this, talk about your manufacturing. A big part of your manufacturing was 3D printing.
yes.
So I'd like to hear a little bit about.
Yeah, follow me.
Okay,
Yeah,
let's go for it.
Let's see
Okay.
first.
I'll
And
keep
then,
driving.
keep driving down. You can see like all the cars that have the parts here that are getting pushing down the assembly line.
I'll just do a pan and take a look down your assembly line here. Now, do you use robots in your manufacturing?
Not yet.
Not yet?
But
Okay.
the idea is the robots can assemble new robots in the future.
Okay. I haven't been on this tour, but we work a lot with Fanuc Robotics out of Japan, and
Right.
they have a factory of robots manufacturing robots. So that's if ever you get to Japan and have a tour of the Fanuc facility, that could be a cool thing for you to check out.
Right, coming down this. So this is our secret sauce.
Okay.
This is a room full of 3D printers. We design and build the printers ourselves. It's been a few generations now. But
Wait a second. You said you also build your own 3D printers?
that's right. Yes, we design and build our own printers so that we get the right finish, the right yield, make it very easy to maintain and to manufacture. We actually use the 3D printers to print the next batch of 3D printers. So that's why I said it's getting there.
For sure, for sure.
So you can see the printers here. This one has worked. So if you focus on, you can actually click on the magnifying glass.
Okay.
And zoom in like 2x, 3x to see up close.
I'm going all the way to 3x.
Yeah. And then use like R and F to there we go.
There we go. So how many 3D printers do you have running?
We have about 100 printers
Wow.
at this facility. Yeah.
And so I have one at home, and I always wish it could go faster. Would you say yours are faster than the industry standards?
It's not just fast. It's not speed. Is one aspect, right?
Okay.
But the quality is also very important. We want to make sure that when the parts come out of the printers, we don't need to do any post processing.
Yep.
The parts can be used for assembling the robots right away.
Right.
And that means they're passing all the engineering tests, right, for the part.
Okay. Okay.
Yeah, maybe come down this way, then see more.
Okay, we're going through a nice tight area here, so I have to be
You're doing
careful.
great.
Yeah, okay.
So the beauty of using 3D printing is we can print something like this in one shot. And so this is the base of the robot.
Okay.
Very durable. It actually passed my standing test. I can stand on it. Yeah. And so, yeah. And because we can actually print very interesting structure support, right?
Yeah.
For the parts. And so this way is actually even more durable than, say, injection molding.
Yeah.
And we don't have to assemble multiple parts, to make one.
How many different variants of robots do you typically go through your facility at any moment?
Yeah. Sorry, could you repeat?
Yeah, sorry about that. Yeah, I was trying to get a feel for how many different variants of a robot go through your manufacturing. Like, does this?
Yeah. Right now we have the two main products.
Okay.
One is the Telepresence robot, and the other one is the UV disinfection.
Okay.
But with the Telepresence, there are a couple of models, right? Like the basic, the pro, the autonomy, and so yeah, I would say about 3-4 different versions of robot. Come on down here.
Okay, let's continue.
And you can see like all these all the on the right hand side of yours.
Yeah.
Yeah, you can see like the hanging out part.
So when I bought my,
I don't know if you can see. Sorry.
Oh, I was just going to say, when I bought my 3D printer, I went through a number of YouTube channels, and the one that was most impressive was at that time was they were doing custom Nerf guns, and so they showed their setup with all the 3D printers. But I think you top it. This is a pretty cool setup you've got here.
Right, but you can see, if you can zoom in the parts here,
Okay.
You can see like the structure, the design is actually quite intricate, right? And yeah, so this allows us to make parts like that, the 3D printing.
Oh, very interesting.
Like this here.
And what type of material are you printing that you use?
Typically PLA.
PLA. Okay.
Yeah.
Okay.
But of course, we can use other plastic-based material as well.
Do you do any metals? 3D printing of metals?
No, not right now.
Not right now. Yeah.
But essentially, what's really cool about 3D printing is that it's not only allow us to sort of manufacture on site, on demand, but it's changed the mindset of the whole company, right?
Yeah.
Now we become almost like a software company because we can iterate very quickly. Engineers are willing to experiment with different models, with a different solution. They just send it to the printer, and you print it out, and you assemble them. The next day, you have a new robot to test out.
Yeah.
So this is incredible, in terms of like the speed, in terms of customization, iteration, and the overhead cost is very low. You don't need to make the molds.
Yeah.
These are really
Yeah. I could imagine, with your modular platform, you must see all different types of applications that, to be able to iterate quickly would be a core part of your business.
That's right. Absolutely. Yeah. This is the end of the tour.
Okay.
Maybe we'll get back to the team view.
Yes.
So that,
Okay, good.
Did you have fun?
That was great. Thank you for the tour. It was everything I thought it would be. I think I felt like I was the remote education in the community.
Actually, we have use cases, with people using the robot for inmates for education to connect and give lectures to inmates in real life.
In real life, so that wasn't fiction. That was a true story.
So we have a lot of use cases in education with the Telepresence robot.
Yeah, I during the pandemic, we resorted to, so we deliver into 17 countries as well, and we went all virtual. So we had our solution was a set of HoloLens, and we would give customers virtual visits, but one of us would have to be essentially the robot. And we were kind of out of the tour, and then we would have another person. I think this was much more engaging the fact that I was able to drive the robot around and look around and zoom in on things, it gave me more of a feeling of being there.
The mobility and independence, right?
Yeah. So it was really nice. I really had a lot of fun there.
I'm glad you enjoy it.
Yeah. So, just to talk a little bit in general about robotics. So how long have you been involved in robotics? And what got you interested in it?
Yeah, so all the way back in undergrad, Jared, my co-founder and CTO, Jared and I were roommates back then at Carnegie Mellon.
Okay.
Yeah, and that was early 2000. So you can sort of guess my age. But we did a lot of research projects in robotics, including robot soccer. So like those Sony eyeball dogs that playing soccer against each other. And we got the interest started there. We got really enjoy the robotics research and development process. And we both got into Stanford for a PhD, but it sort of went separate way. I finished my PhD and I started my first company called Katango, and it was acquired by Google. So I ended up at Google for a few years. Jared left Stanford to pursue his first startup, Hopnow. And so that's how we went separate way. But we got together in 2015, and we were asking the question, what would be the next big thing that we should work on together, right? Because we enjoy working together so much. And the natural answer was robotics. But I think the angle here is slightly different. The promise of robots helping people, helping the world, it has been around for decades, right? But you don't see a mass adoption of robotics solution in everyday life setting, right? Except for the Roomba, right? If you call that a robot. And so we look at that and we're like, okay, we want to change that. So we want to build more robots that can be deployed in schools, hospitals, restaurants, home, right? And interact with human and help improve their quality of life. And so that's how we started OhmniLabs.
Yeah. Okay. Now, on this side of the screen, my experience driving the robot around, I think, you guys did a great job in terms of the responsiveness of it and how intuitive it was. Now, in your experience on the other side, people seeing this robot drive through, what has been important in your design, thinking about how people react to the robot? And I think about one of my previous podcasts, I interviewed a gentleman, Lenton Joseph, and he spent time, he's from India, and he spent time on social robots. And I think that's a bigger thing in Asia, thinking about how the robot interacts with the person and, the gestures and stuff like that. For your work and the experience, what's been important for people being comfortable around a robot?
Yeah. So I think there is what the robotics is usually called uncanny valley problem, right? If you're getting too close to a human being, but not quite there yet, then the robots look really weird and sort of turn people away. And so we decided from the beginning that we want to aim for a minimalist design, something that not taking up too much space, unobtrusive. Sort of blend into an environment. It's just like a something supposed to be there rather than standing out. And so we opt for like having like a screen on like a slim body and then a movable base. That's how we thought about the design. And so far, I think in the beginning, usually when people first saw our robots, it always turned head.
Yeah.
We're getting a lot of attention. But people get used to it, and it becomes just like another person in the office. Sort of an embodiment of the remote controller.
Yeah. I think it takes time to let it become commonplace, right? First we'll talk about it a lot. We'll maybe try and regulate it more, and then we'll realize it's really helping us, so the disinfection, once that as that takes off, I think it'll become an important element of society at that point.
Yeah, and the one of the area or like philosophy that we focus on is that we don't want to take away jobs, right? But more like we want to augment people's work, and really taking away some of the hard part, the boring part, even dangerous part, so that people can focus on things that they enjoy more. So same with disinfection, right? To disinfect an operating room, it's actually really hard work. You have to spray the surface. You have to like manually scrub it. You have to make sure the surface is wet for like at minimum 3 minutes. And a lot of time people would miss spots, and and then it's like dangerous, right, for the patient. And so so having an autonomous solution make a huge difference here.
And do you guys have any tools that help, kind of show where it has been disinfected, and some
Absolutely.
of those things you were talking about? Was that surface, was the exposure time long enough on that surface? What type of tools do you have to approach that?
Yeah, so a couple of different things, right? One is the sort of like a dosimeters to measure the strength of the UV light. And so as long as we satisfy certain minimum requirement, then we know for sure that we can achieve log 5, log 6 of reduction. Basically, killing 99.999% of bacteria or viruses. And then the other thing is reporting, auditability. This is very, very important because with manual cleaning, management team would have no idea how clean the room has been, and what are the spots that have been cleaned or not. But with the robot, you know exactly where the robots have been going around, and how long it stay in each spot to achieve the minimum requirement. And you can dial up or down. Say there's certain spot that's more sensitive, more traffic, then you can actually increase the time the robot's spending there to make sure that we have a lot of UV strength coverage for those spots.
That's interesting. So the application I told you about here at Montreal General Hospital, so the next step for them was to put together a research grant where they would, go into a room, manually put some some foreign bacteria or something they could track in the room, bring the robot in, let it do its thing, and then measure afterwards. So the fact that you guys have tools for that to help with that approval process, I think that's a big deal.
And we do have that test report as well to measure the culture after we have put through UV disinfection with our solution. And so they don't have to do all that research. They can just come talk to us.
Absolutely. The easy button is there. So so what are some of the we talked about disinfection, we talked about telepresence. What are some of the really cool, interesting applications you've seen that maybe is like a one-off and you can't build a business around it, but yet you still thought it was a really great, cool application?
All right. So that's actually a very, very tough question, right? There are way too many cool applications of robotics. So, in general, I'm most excited about, I guess, robots that, can be deployed in social setting that can work alongside human beings and help them with their tasks. And so I think, those are the key area that I'm usually focused on. But if you really push me to pick one, I think rescue robots is really interesting. Robots that can go through like after an earthquake, right, can get into all the houses and trying to find survivors. I think that has very, very strong meanings and impact for all of us, but not so much of a commercial potential as you were putting it.
Yeah, I agree with you. I mean, from the importance of that type of application, it's huge. And then the challenge of it too, the different terrains and like,
Yes,
going into
that's
that,
right.
that for a technical challenge, that's also quite fascinating as well.
Yeah.
Now, you talked about how many different countries again did you say you have robots deployed in?
48
48. That's
in
great.
48
Wow.
countries.
Now,
Yeah.
top countries that are embracing robots. Who's out there really embracing this type of technology?
I would say East Asian countries
Yeah.
are like the top adopter of robotic solution right now. And I think Europe and US actually lagging behind. Countries like China, Korea, Japan, Singapore, they are really out there and getting robots into manufacturing, into everyday life.
Yeah. Yeah. I I tend to agree with you. And I think just technology in general, I think they're much quicker, especially in society and in the public, they're
Yeah,
much quicker to bring it in and a little bit less worried about, surveillance and stuff like that, and maybe it's because I've heard there's maybe more trust, like South Korea during the beginning part of the pandemic, how they managed it with some of the software and AI, and there was more trust in the government. Is the storyline that I heard, for them to deploy that and everybody to work together and adopt it. So it's interesting dynamics as well too.
yeah. And I think generally, I think for Asian country, right, some of the countries, the privacy issues are not like too critical yet,
Yeah.
right? And so, in some sense, there's good and bad, right? Both sides. But the robotics company don't have to deal with a lot of restriction for that, and so it's just easier for them to get adoption.
Yeah, yeah. I've got a current event, so this is really fresh off the press. So I'd like to get your take on it. But in California, there was new legislation passed, and it's being challenged, but where they've created a fast food council. I don't know if you've heard about this, but essentially, the state of California, if a restaurant has more than 100 chains, they're obliged to have a minimum wage of $25 an hour for their
Uh,
employees. So one of the podcasts I was listening to, they were saying, the companies like McDonald's, they're actually, when it comes to pricing their food, they've got a lot of data and they know what the customer can bear and what it
right.
cannot. And really what this legislation will do, it's not necessarily going to protect jobs. It will welcome a business case for
Okay.
more robotics within
Yeah.
the restaurant. So
Yeah.
judging by your reaction, I'm not sure have you heard about this regulation yet?
Yeah, I heard about something similar with
Okay.
like because we had to deal with that as well
Oh
in terms
yeah.
of like
Okay.
getting compliant, right? So yeah, I think it's just it's an interesting issue, and that there are always two sides of the consideration, right, for the politicians to pass.
Yeah.
Yeah.
Yeah. And who knows, maybe we'll see, it'll create more use cases for robotics. That's one side in terms of innovation. Uh, you're right, there's both sides of the coin. So, will that
Yeah.
take away jobs from people? At one point it could. But what I found in manufacturing is if the manufacturing here in North America didn't embrace technology, that
Mhm.
the manufacturing facility would disappear. So they would move it overseas. So the mindset changed and people were willing to embrace technology to keep manufacturing there. I don't know if it equates well for fast food because everyone needs to eat. So you
Right.
can't just move it somewhere else and people stop eating, right? So how that will change, that's interesting. Maybe our fast food will be more expensive and will be healthier at
Yeah.
one point, right?
Yeah. Yeah. I think it's that yeah, I think that's a really interesting point. You know, I believe that robotics development and progress would actually create a lot more new jobs as well, right?
Yeah.
Of course, certain jobs will be taken away. Just like the internet, before we had the internet, or when internet is getting more adoption, people worried about the internet is
Yeah.
taking away jobs and things like that, right? But now we have web developers, we have graphic designer, all sort of things that created around this ecosystem. And so I think it's going to be the same. What will happen was that some of the repetitive, boring tasks that could be done very well by machines will be replaced by robots. But there are some tasks more on the creative side, more ad hoc. For example, like training the robot,
Right.
or provide maintenance, right? Fixing robots. I think we'll have a lot more of those type of jobs in the future.
Yeah. And I imagine for you're talked a little bit about the internet, and I look into the try and see the trends in which way things are going, and what role do you see the internet playing in robotics? I think, do you see it? We just did a telepresence through the internet, and that was a big deal. Do you see more elaborate control systems, or do you see more centralized control systems being opened up, or what possibilities do you hope for coming out of that?
That's interesting. So I would like to unpack your question a little bit more. Are you thinking of like some sort of central authority that will govern the robots through the cloud? Or you're talking about like more like infrastructure design for the robots to get access to the web and
Well, I guess let's fast forward 20, 30 years, and let's think about Uber, right? And when we have self-driving cars, I think a lot of the controls of the car itself, like in safe driving, will be on the machine, but in terms of what job does it do next, where does it go, what's the optimal route, I think the internet will become the control system of choice for those type of for those type of decisions, and enable those kind of like widespread solutions.
That's a very, very interesting point. So I think it's going to be similar for robotics. Essentially, the cloud enable massive exchange in terms of information across different robots, right? So one robot can learn about the environment, let's say do a mapping and share to the cloud, and now all the other robots will have that mapping. And it also, it's just a way for for us to control, coordinate,
engage,
like a fleet of robots. Much easier. Let's say, I can assign different tasks for a team of robots to finish, just like playing soccer, right? Different positions have different, type of robots. And so I think that's where we will be heading.
Yeah, makes a lot of sense. One of the roadmaps that I like to keep up on, there's the US robotics roadmap, where they every 5 years they take a step back and say, okay, what's the state of the industry? What are the obstacles moving ahead, and what should people be working on over the next 4 to 5 years? Without giving away any secret things that you guys are working on, but in general, what are the key things for robotics over the next 4 to 5 years that you think are important for the industry to solve?
So from our opinion, right, for the type of robots to get mass adoption, it will need to be able to provide value higher than the cost. And so for value, the robots need advanced capability that can perform tasks that for the end user. And so on that front, I would say computer vision is going to be one of the key, allowing the robots to recognize and understand the environment, right? The objects, people, what are people doing, their behaviors. So that's going to be very important. And then second part is manipulation, how the robots going to manipulate the objects in the real world, picking up, moving around, call the elevator, open doors, right? So that's the second area. And then I think the third area is probably going to be on battery. How do we get, longer battery life, lighter, faster charging, safer, right, for these. And so those are the technology, advances that we need. And then on the manufacturing side, the cost is going to be a huge, huge factor for adoption. So we just need to continue to bring down the cost to make it affordable for people, for companies to buy these robots.
Yeah.
And then the last part, I think, is safety. And that would include regulation and some restriction, right? Robots going to be increasingly working alongside of human. So how do we make absolutely sure that the robots will not harm people? Right? Self-driving car is one area in which is still an ongoing debate. And so, those are the three main areas that I see still need a lot of innovation.
Yeah. In the manufacturing space, the safety part is big, and because of that, we became quite good at it. Like we've got the robotics industry standards and stuff like that. So translate that into an office space. How do you guys approach safety? Is there, if I'm interested in one of your robots, is there some guidelines that you guys can walk us through that enable any questions and ensure that it is safe?
Yeah, so the safety started with the design of the robot, right? So, for example, lightweight is one area in which would allow us to keep the robot on the safer side when it's moving around, so that it doesn't hurt people when it bumps into people, right? And then advanced capability, autonomy is the second area. Having the LiDAR or depth sensing camera to recognize obstacles, to recognize people, and stop the robot when it's getting too close to anyone is one area that we can improve and then deploy. And then the third part, I think a bit more in the future would be really understanding people and what they're trying to do, sort of like the behavior, right? Is this person lifting, trying to bring one item to another? Is this person is cooking, or is driving, right? All these will get into the decision making loop for the robot.
Yeah. I see what is happening in the self-driving cars, and there's a lot of that decision making being worked on. So I think there could be a great crossover where when there's going to come a tipping point where we will be able to merge some of that decision making into the world of robotics, and it's really going to change things and accelerate it.
Yeah. I love that, essentially sort of like an open source robotics platform, right? That allow people to develop and share a lot of these technology.
Yeah. Open source has opened up so many different areas in technology. I remember machine vision when I started. So I graduated university in 2000 as well too. So I think it puts us about the same age. And OpenCV was around back then, but that's not what, and very powerful library even back then, in 22 years ago, but that's not what opened up the world of machine vision. It was more the smart cameras and things like what you're doing with robotics, making it easier to innovate with your modular robotic platform. So I think the work that you're doing is very important to growing the industry and moving things forward.
Thank you.
Yeah. So to go a little bit outside of robotics and what we do every day for work, I always like to ask, what do you do in your spare time? Maybe I'm bringing you back into robots, but
yeah. Yeah. I enjoy reading and listening to podcasts. I listened to a few of your episodes, so really enjoying it, especially the one on 3D printing and the democratizing robotics. So I love those episodes. So yeah, kudos to you.
I appreciate that. Appreciate that. What's the book on your shelf right now?
So there is on the shelf right now. We have a couple of different books, but one is on channel partners. That's something that I am reading right now.
Yeah.
And then also a book, Thinking Fast and Slow. Is on human cognitive bias.
I've read
fascinating
that one.
book. Yeah,
It's really good. And it helped, actually, personally speaking, it helped me because in my world at work, there's some at times you can go fast because you've figured something out, and then there's some times where things kind of bog down and you got to let yourself digest what's going on. And it helped me work with my R&D teams and stuff like that and understand, what, sometimes we just need to let a little time go by to process what's going on here. That's a great book. I recommend it too.
Yeah, absolutely. And what's really interesting is if you think about from sort of like the robots versus human angle, right? Human have a lot of cognitive bias. So, next question is, what are the bias that a robotic solution would have, right?
Yeah.
And it could be bias in terms of training sample. It could be sensors limitation. It could be even like on purpose from the developers, right? So this is really interesting to see the contrast between the two worlds or sides of the
the big one that I always hear people debate, and this is going back to self-driving vehicles, is a car is approaching an intersection and it ends up in an emergency mode. Someone is going to get hurt, and in front of them they've got a 12-year-old and they've got an 80-year-old. How does the car pick which one is the one that gets hurt? Like, what a crazy question, right? I don't want to answer that question.
Paradox.
The paradox, right? So there's a lot of juicy ones.
I think to answer that question, it will take many different areas together, right? Not only on the technical side, but the legal side, the ethical side, and even like human psychology. So it's I think it's going to be an ongoing debate for a long time.
For sure.
With that question.
Yeah, we'll see how we are as a society, how mature we can be, right?
Right. Absolutely.
Well, Thuc, this has been great. It's been a lot of fun. I appreciate you opening up your door and the hospitality, and it's been a fascinating conversation together.
Yeah, thank you so much for having me, and I really enjoyed your visit and also our chat as well. So
very good. Thank you.
Yeah.